Space, the final frontier. For an egg, space is vast, it's cold, it's unforgiving. It's a place where the rules of Earth don't apply and the stakes are higher than ever. And it's where we're sending... an egg? Yes, you heard that right, an ordinary everyday egg. But why, you ask? You heard right, folks. Today we're diving into a question that's as intriguing as it is messy. What happens when an egg takes a little tumble from the cosmos? What happens when an egg takes a little tumble from the cosmos? Will it crack under pressure, or will it defy the odds and make it back to Earth in one piece? Buckle up, space cadets. It's going to be a wild ride. We're about to embark on a journey that will test the limits of our understanding and push the boundaries of science. We're talking extreme temperatures, mind-boggling speeds, and enough atmospheric pressure to make a pancake jealous. Imagine the egg hurtling through the atmosphere, facing temperatures that could fry it in an instant, and speeds that could turn it into scrambled eggs. Can our fragile friend, protected only by its delicate shell, survive this epic journey? The egg shell, though seemingly fragile, is a marvel of natural engineering. But is it enough to withstand the harsh conditions of space travel? The answer, my friends, lies not in the stars, but in the fascinating laws of physics, and a little bit of good old-fashioned scientific curiosity. Scientists have long been fascinated by the resilience of eggs, and this experiment will put their theories to the ultimate test. Let's crack this thing wide open, shall we? Join us as we explore the final frontier, not just for mankind but for an egg. It's a journey you won't want to miss. A cosmic omelet, the egg in zero gravity. First, let's picture our egg free-floating in the vacuum of space. It's a surreal sight, isn't it? An ordinary egg, something we see every day, now adrift in the vast, infinite expanse of the cosmos. The egg, with its delicate shell, seems so out of place among the stars and galaxies. Yet here it is, defying our expectations. Gravity, that ever-present force here on Earth, is practically non-existent in this environment. On Earth, gravity pulls everything towards the center of the planet, giving weight to objects and keeping us grounded. But in space, far from any massive celestial body, gravity's influence wanes. Our egg, now free from the clutches of gravity, experiences a state of weightlessness. Our egg is weightless, spinning lazily as it hurtles towards its destiny. It rotates slowly, almost as if it's dancing to a cosmic tune. This gentle spin is a result of the initial forces acting upon it when it was set adrift. In the absence of gravity, there's nothing to stop its motion, so it continues to spin, a graceful ballet in the void. But what's going on inside that shell? The egg's interior, a delicate balance of yolk and albumin, is now in a unique state. On Earth, gravity causes the yolk to settle at the bottom, surrounded by the albumin. But in space, the lack of gravity changes everything. Here's the thing, space doesn't discriminate. Whether it's a massive star or a tiny egg, the same principles apply. The laws of physics are universal, governing everything in the cosmos with impartiality. This means our egg, despite its humble nature, is subject to the same forces and principles as the grandest celestial bodies. The laws of physics apply to celestial bodies and breakfast staples alike. This universality is what makes space so fascinating. It doesn't matter if you're observing a distant galaxy or a simple egg, the same rules are at play. This consistency allows scientists to make predictions and understand the behavior of objects in space. Without gravity to pull the yolk down, it remains suspended, a yellow orb in a sea of albumin. This suspension creates a beautiful, almost otherworldly sight. The yolk, usually nestled at the bottom, now floats freely, surrounded by the clear, viscous albumin. It's a delicate balance maintained by the absence of gravitational forces. The egg's internal structure, normally so vulnerable, is strangely undisturbed. The lack of gravity means there's no pressure causing the yolk to settle or the albumin to shift. Everything remains in a state of equilibrium, a perfect balance that would be impossible to achieve on Earth. It's a reminder that even in the most extreme environments, nature finds a way to surprise us. The egg, a symbol of fragility and new beginnings, shows resilience and adaptability in the harshest of conditions. This phenomenon is a testament to the wonders of nature and the endless possibilities that space exploration holds. Entering the furnace Earth's atmosphere awaits. Our journey begins as our space egg crosses an invisible line, the boundary of Earth's atmosphere. No longer in the peaceful vacuum of space, it encounters air resistance for the first time. This friction generates heat, and lots of it. Imagine a spacecraft re-entering Earth's atmosphere, glowing red-hot from the friction. Our egg, though much smaller, experiences a similar phenomenon. The intense heat could bake that shell in an instant, turning our experiment into a fiery meteor shower of scrambled yolk. But don't count our egg out just yet. Splat or scramble impact probabilities. Now for the million-dollar question, does it survive the fall? Here's where things get tricky. The egg's fate depends on a few factors: the height of the drop, its angle of entry, and a little bit of luck. Let's say our egg is dropped from the International Space Station, a mere 250 miles above Earth. At that height, it might actually have a fighting chance. Section 5: Space Eggs and You Culinary Curiosities. Now you might be wondering, what happens if you bring one of these space eggs back to Earth? Can you fry it up, scramble it, make an omelet fit for an astronaut? Well, hold your horses, culinary explorers. The truth is, we don't have all the answers yet. Studying the effects of space travel on food is still an ongoing field of research. But one thing's for sure, cooking in zero gravity presents a unique set of challenges. Imagine trying to crack an egg when it won't stay put. Section 6: The Yolks on Us, Debunking Common Myths. There's a popular misconception that an egg falling from space would reach terminal velocity and become an unstoppable projectile. This idea has been perpetuated by various media and even some educational sources, leading many to believe that such an event could cause significant damage. While it's true that objects falling through the atmosphere eventually reach a maximum speed, known as terminal velocity, the specifics depend heavily on the object's size, shape, and mass. For instance, a meteor, which is dense and often large, can indeed become a dangerous projectile as it hurtles towards Earth. However, the egg's small size and lightweight mean its terminal velocity wouldn't be nearly as destructive as some might imagine. In fact, the terminal velocity of an egg is much lower than that of a denser object. This is due to the egg's relatively low mass and the significant air resistance it encounters as it falls. In reality, the egg is far more likely to burn up completely, or shatter into a million pieces upon impact. The intense heat generated during re-entry into the Earth's atmosphere would likely cause the egg to disintegrate long before it could reach the ground. Even if it somehow survived the heat, the impact with the Earth's surface would almost certainly cause it to break apart. So, rest assured, you don't have to worry about cosmic eggshells raining down on your parade anytime soon. The next time you hear someone worrying about eggs falling from space, you can confidently debunk this myth with the facts. It's always fascinating to explore how science can clarify and dispel common misconceptions, making our understanding of the world a little clearer. Section 7: To Boldly Go, Further Explorations in Extreme Science. The journey of our space egg, hypothetical as it may be, opens up a universe of possibilities for scientific inquiry. By studying how objects behave in extreme environments like space, we gain a deeper understanding of the fundamental laws that govern our universe. Imagine the possibilities. What if we could design heat shields inspired by the structure of an eggshell? Or develop new materials that mimic the egg's ability to withstand extreme temperatures and pressures? The sky's the limit, or should I say, space is the limit. Section 8: Beyond the Breakfast Table. The bigger picture. The humble egg, a symbol of new beginnings and breakfast staples, becomes a powerful metaphor for the fragility and resilience of life in the face of the cosmos. It reminds us that even in the vastness of space, the laws of physics connect us all. And who knows? Perhaps someday we'll be enjoying space-baked omelets on our way to distant galaxies. Until then, keep looking up, keep asking questions, and never stop exploring the wonders of the universe, big and small. Section 9: Cosmic Food for Thought, leaving you with a bang. So, there you have it. The incredible journey of an egg from space to Earth, a tale of fiery descents, atmospheric pressure, and the eternal question to splat or not to splat. As we conclude our cosmic adventure, I leave you with this. What other everyday objects would you like to send on a one-way trip to space, and what could we learn from their journey? Keep those imaginations sizzling, and remember, the universe is full of surprises just waiting to be unraveled.